Hi, I am John Bell, Application Engineer at Circuit Design Japan. In today's video, we are going to talk about how to create a proper channel plan. To begin with, an engineer who wants to use a radio module needs to decide on the number of frequency channels, let's say 32 channels as an example. Now, if the engineer assumes that all 32 channels can be used at the same time, we have to say that this is not the case, and I will attempt to explain so in this video. If the spacing between radios is small and their frequency channels are used close to one another, there are two problems which are at play, and they are third order intermodulation, interference, and the near-far problem. So, how many of the 32 channels can we use at the same time? Well, in actuality it turns out to be only 5 or 6. So in order to explain how I arrived at this answer, I am going to introduce our third order intermodulation prevention technical tool. The phenomena just mentioned are explained in a separate link found in the same page, which I will not cover in this video. In this example, I will use one of our top selling RF modules, the STD302Z 434 MHz, as an example. So first we need to find that technical tool page, which we can do by going into resources, then in technical tools, then click here to go to the calculation tool page. So we begin by starting at the top where we select our region and frequency band, which in this case will be 434 MHz. Just below that we can select the finer details to create our channel table. Our ST302Z 434 MHz uses 25 kHz spacing, so this is the option we will select. The channel spacing is the default for this module, but you can input another value manually if you wish to do so here. If your desired channel table does not appear in the list, it is possible to customize your own channel table. From the top we have start channel, end channel and frequency. However, for the ST302Z 434 MHz, these are already correct, as is the channel span of 25 kHz. But then if, for example, you want to change your start frequency to 433.1 MHz, you can enter this value in this box. Of course, to keep the channels in band, you would need to reduce the end channel like this. Here we have a disable adjacent channel selection. By default it is enabled to allow the tool to warn you of any interference due to adjacent channel use, but by unchecking it you can disable this warning. Once we have entered our parameters, we can click Initialize button and we are all set to go. So we can begin the simulation. Let's select 433.1250 MHz as the first channel. You can do this by checking the box next to the frequency. Our selected frequency is now highlighted in green. As we have checked Disable Adjacent Channel Selection, the values on either side, in other words adjacent of our frequency, are highlighted in yellow, indicating these are forbidden channels. The frequencies not highlighted are selectable. Next we select 433.2 MHz. As before, the frequencies on either side have been highlighted. So now we choose another vacant channel. Let's choose 433.250 MHz. Ignoring the highlighted adjacent frequencies, we can see that due to third order intermodulation, the frequencies 433.3, 433.325, 433.375 are highlighted in yellow to indicate forbidden channels. If we attempt to select 433.325 that is already in yellow, then the tool indicates our selections as error, which is shown in red. So as long as we select the frequencies not highlighted, we can create a channel plan. If we press Initialize once more, all the checked frequencies will be cleared and we can begin the simulation again. When using circuit design radio modules, you can look at our various technical tools that we have prepared. To access them, go to Resources, then Technical Tools. On the third order intermodulation technical tool page, if you scroll to the bottom, you can see a guide on how to use the tool and more insight about third order intermodulation and near-far phenomenon.